Bismillahirrahmanirrahim. My dear students of first year class, today we are going to have our first lecture, Mathematics. I am your mathematics teacher Muhammad Anjas Saeed from Pakistan International School, Taif. First of all, before we start our exercise, I have to say something about the rational numbers, irrational numbers, terminating, non-terminating, recurring, non-recurring decimals. First of all, a rational number, what is meant by rational number? A number which can be written as P over Q form, where Q is not equal to 0 always. Remember that if Q is equal to 0 in the denominator, that will become math error. You can check from your calculator. Something over 0 is always equal to infinity. So Q must not be equal to 0. This is known as rational number. All integers, all odd numbers, all even numbers, they are rational numbers also. Because any number can be written as 3 over 1, 4 over 1, 5 over 1, minus 3 over 1, minus 10 over 1, like that. So they are all rational numbers. Irrational numbers are those which cannot be written in this form, and they are actually incomplete square roots. Incomplete square roots, I am repeating. For example, this is 2 under root. It is incomplete square root. This is 3 under root, incomplete square root. Here is 4 under root, but 4 under root can be written as 2. So that is equal to 2 over 1. So this 2 is rational number, 4 under root is rational number, but these are incomplete square root. For example, 5 under root, 6 under root, 7 under root, 8 under root, and 9 under root. Again 9 under root can be written as 3, that is 3 over 1, so it is rational number. So dear students, I hope that you got the idea about rational numbers and irrational number. You have studied in the previous exercises and in previous classes even, in class 9 even, in class 8 even, that what is meant by rational and irrational numbers. After that, terminating, non-terminating. Terminating means the fraction which has an end. For example, this is 1 over 2. When you divide it, it will be 0.5. This is terminating. 1 over 4, 0.25. This is terminating. But on the other hand, you can check for example, we have 8 over 9. What will be that? You can check with the help of calculator. This is 8 divided by 9. It will be 0.88888888 up to so on. Remember that you can check. Here is indefinitely repeating. This is non-terminating and also recurring. Recurring means which is indefinitely repeated. For example, you have 0.5 bar. Dear students, you have seen this question in your chapter number 2, 9th class, exercise 2.1. And that was your last question. 0.5 bar means 0.5555555, like that. This is known as recurring decimal. So 0.5 bar, similarly, In your first year syllabus, for example, we have 0.67 bar or 0.6.7 dot. In ninth class, it was written as 0.5 bar. In your first year syllabus, it is written in chapter number 6, 0.67 bar dots. It will be written as 67, 67, 67, 67. Now the block of 67 is repeated indefinitely. So this is known as non-terminating and recurring. Non-recurring means, for example, you are having 0.01010011000011. So this is different. You can see all numbers are different, no repetition. So this is non-recurring, but it is non-terminating, has no end. So my dear students, so far we have discussed about rational numbers, irrational numbers, terminating fractions, non-terminating fractions. These are non-terminating. Recurring fractions, they are indefinitely, infinitely repeated, and every number is coming after the number and having, for example, this is 0.67 dots. This is block of 67 which is repeated. Okay, so this is recurring, and non-recurring are those which are not having any order and not continuously repeated. Sometimes there is a difference between them. So that was your idea about your number system, which is used in chapter number 1. After that, very important example, page 3. You can check from the book. Question is, prove that 2 under root is an irrational number. Prove that 2 under root is an irrational number. My dear students, this is your question number 1, and I have seen so many times in your exam, in your test, in your board exam even, this 2 under root is an irrational number, 3 under root irrational number, 11 under root irrational number, 5 under root irrational number. So exactly on the same lines you can do other parts, other irrational numbers. First of all, we will suppose oppositely. We will suppose oppositely that 2 under root is not an irrational number, but it is a rational number. Let us consider 2 under root is a rational number. You know that if 2 under root is a rational number, then suppose 2 under root is equal to P over Q, where Q is not equal to 0, and very important factor is P and Q are in the lowest form. They do not have any common factor. The important point, this is key point in your question. Suppose 2 under root is equal to P over Q, Q is not equal to 0, where P and Q are in lowest form, that is, they have no common factor. They have no common factor. They have no common factors. Here is, so 2 under root is equal to P over Q. This is your equation scaling both sides. The basic concept is they have no common factor and we will reach the contradiction. If we reach the contradiction, it means that what we supposed, it is wrong. So what is correct? It's opposite. Scaling both sides of equation 1. This is 2 is equal to p square over q square. Or 2q square is equal to p square. Suppose this is equation number 2. From this equation number 2, we can see 2 is a factor of left hand side. 2 is a factor of left hand side. So right hand side must have the factor as 2. Otherwise equation will be wrong. This equation cannot be equal. Again I am repeating. In equation 2, left hand side has 2 as a factor. If left hand side has 2 as a factor, then 2 must be the factor of right hand side. Otherwise this equation will become wrong. So you cannot have these two equations equal. Left hand side has 2 as a factor, so right hand side must have 2 as a factor also. Then let p is equal to 2p dash. Suppose this is equation A. If we have 2 as a factor of right hand side, then p must be 2p dash. So using this equation, using this value of p in equation number 2, using p is equal to 2p dash in equation number 2, 2q square is equal to 2p dash square. That will be equal to 2q square is equal to 4p dash square. Dividing both sides by 2, you will get q square is equal to 2p dash square. Suppose this is equation number 3. Same logic, just like the logic of equation number 2, that in equation 2, right hand side has 2 as a factor. So there must be 2 as a factor of left hand side. So from here, in equation 3, I can write down on the whiteboard in this way. In equation number 3, right hand side has 2 as a factor, so left hand side must have 2 as factor also. Then let q is equal to 2q dash. This is B. So using q is equal to 2q dash in equation number 3, we have q dash square is equal to 2p dash square. Here is 4q dash square is equal to 2p dash square. That is p dash square is equal to 2q dash square. So you can see that even we have changed the number and applied the rule that 2 is a factor of left, right hand side. This will be similarly for both here. Then using equations A and B in equation number 1, that was 2 under root is equal to 2p dash over 2q dash. Instead of P, we have written 2P dash and 2Q dash. What was our supposition? That P and Q right hand side will not have any common factor, but which is the contradiction? Both have 2 as a common factor. Which is contradiction? That P and Q have 2 as common factor. Hence, our supposition is wrong. Hence, our supposition is wrong. Thus, 2 under root is an irrational number. Dear students, that was 2 under root. In case of 3 under root, 5 under root, 7 under root, 11 under root, you will have 3 as common factor, 5 as common factor, 7 as common factor, 11 as common factor. So exactly on these lines, 100% same. Simply you will change the factor. It was 2. In case of 3 under root, 3 will be factor, 5 will be factor, 7 will be factor, 11 will be factor, like that. So I hope that you can solve the question, prove that 11 under root is an irrational number. This is for your practice. Exactly, you will keep your previous part in front of you. Then write down 11 under root is a rational number. 11 under root is equal to P over Q. P or Q have no common factor. They are in the lowest form. Then scaling both sides. In this case, 11 will be your factor of left hand side and eventually on right hand side, and you will take P is equal to 11P dash and Q is equal to 11Q dash. I hope that you will do it. You understand that? Hopefully you can complete this question by using what we have proved in 2 under root. After that, we have properties of real numbers. What is meant by binary operation? Binary operations, binary operation. In case of binary operation, A cross A to A, you will get this binary operation. This is will be the function from A cross A to A. You have seen this binary operation in 10th class, chapter number 5, last exercise. I am repeating, you have the idea about the binary relation, binary operation. In chapter number 5 in 10th class, last exercise, you have different types of binary relations, and also you have the functions, types of the function. So inshallah we will discuss in detail in chapter number 2, exercise 2.6 in your first year mathematics book. After that, we have the addition properties and multiplication properties. And there is a unary operation. Binary operation means operation between 2. Unary operation means operation on 1. Operation on 1 means taking square of any number, finding square root of any number. That is known as unary operation. In case of binary operation, you need 2 values, 2 numbers, 2 different find the relation between them by negation. After that, addition properties. I am writing down side by side multiplication properties. Number one, closure property. What is meant by closure property? For all A, B belongs to R, A plus B is equal to C belongs to R. Dear students, in case of addition properties, what is closure property of addition is you have two members in any set. If you add them and you get the answer which will be in the same set, that is known as closure property of addition. In case of multiplication property, you will multiply them and that will belongs to R. And answer will be in the same set R, that is known as closure property of multiplication. In case of closure property of addition, you will take two members. For example, we are taking set of natural number two members, 5 and 6. If you add them, what will be the answer? 11. And 11 is also present in the set of natural numbers. So that's why closure property of addition is satisfied in set of natural number. Similarly, in case of set of natural number, I am taking 5 and 6, and if we multiply them, then we will get 5, 6 is 30. 30 is also the member of set of natural number. So we can say that closure property of multiplication is satisfied in set of natural number also. So this is what we want to say, that closure property of addition, two members are required, they are added to get a number which will be in the same set. Two numbers are required, they are multiplied to get a number which will be in the same set, and closure property of addition is satisfied, here closure property of multiplication is satisfied. Number 2 is associative property. Associative property. In case of associative property, you need two values. For all A, B, C belongs to R, A plus B and plus C is equal to A plus B plus C. In case of multiplication, still you will have A, B, C belongs to R. This will be A, B into C is equal to A into B, C. Remember that this is associative property. In case of associative property, we need three values. If you add them in this order, first two are added and C is separate, and then second and third are added and first is separate, you will get the same answer. Similarly, in case of associative property of multiplication, you need three values. You multiply them in this order. First two are added, multiplied, and C is separate. Then second and third are multiplied first, and then A is separate. Then A is multiplied at the end. Left hand side must be equal to right hand side. So associative property of addition and multiplication is satisfied. For example, if you have 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. Suppose this is 2 plus 1, 3 plus 3 is 6, and here is 2 plus 3 is 5, 5 plus 1 is 6. So addition is satisfied. Similarly, 1 into 2 into 3 is equal to 1 into 2 into 3. You can check 1 into 2 into 3, 2, 3 the 6, and here is 2, 3 the 6, 6, 1 the 6. So you can check left hand side is equal to right hand side. So associative property in set of real number is satisfied for addition and multiplication. After that we have part number 3, addition law and multiplication law, that is additive identity. Additive identity. And here is multiplicative identity. What is additive identity? Dear students, you have seen these things already in previous classes, but this is your VN. Additive identity is a number which when added, and you will get the number as it is. Whenever a number is added, a special number is added to A, and you will get A again. A number which is added to B, you will get B again. A number which is added to C, you will get C again. That is known as additive identity. And you must understand that 0 is added to any number, you will get the number again. So that's why 0 is additive identity instead of real numbers. For all A belongs to R, A plus 0 is equal to A, B plus 0 is equal to B, C plus 0 is equal to C, what I told you about. So then, what is 0 is additive identity. 0 is additive identity. In case of multiplication identity, a number is multiplied with any number and you will get the same number. For example, a number is multiplied by A, you will get A again. Number is multiplied by B, you will get B again. Similarly, just like that. Here it was added and here we are multiplying. So which number which will be multiplied to every number to give it again, that is known as 1. So for all A belongs to R, A multiplied by 1 is equal to A, B is multiplied by 1 is equal to B, C multiplied by 1 is equal to C, like that. So which number which is bringing your number again? Definitely 1. So 1 is multiplicative identity in set of real number. My dear students, I hope that you understood that one. And inshallah, in the next lecture, we will continue from here. And you will complete your question which I gave you and revise it properly. I hope that you understood. Okay, Assalamu alaikum wa rahmatullah.